Today we'll be reviewing simplifying rational expressions. Generally speaking, to simplify a rational expression means to rewrite it in an equivalent form, reduced as much as possible. And when reducing fractions, that means we want to have no factors common to numerator and denominator. Now you'll note that I use the word factor, and that's important because in order to cancel anything out, we have to have everything written in factored form. So I'm going to begin by factoring all four parts of these two fractions. The numerator, although linear, will factor into 4 times x minus 1, that quantity. The denominator is quadratic. That'll factor into x minus 2 times x minus 3. The next fraction we have a difference of squares here, so x plus 2x minus 2. And then finally, in the denominator, we have, again, a linear, but two common to both terms. That will factor into 1 minus x. Now I've got everything written in factored form, so now's the fun part. We get to just start to cancel some things that are common to numerator and denominator to reduce the fraction. For example, you'll notice an x minus 2 here and here. Those can be factored. We have an x minus 1 and a 1 minus x. They're not exactly the same, but they are opposite values because subtraction, when you subtract in a different order, you get the opposite. So when you take something like this and divide by its opposite, that will leave behind a negative, so I'll put a negative here. And then the 4 and the 2, I can cancel those out. That would leave me with a 1, and this 4 would leave me with a 2. And whatever is remaining will be my final simplified version. So in the numerator, that would be a 2 times x plus 2. In the denominator, an x minus 3. So this would be an equivalent reduced form of that original problem. Now let's take a look at a second example involving addition or subtraction. In this example, we have a subtraction problem, and we would like to get a common denominator. Now, I'd like to ensure that I get the least common denominator. To do that, I'll have to factor the denominators of each of these. So let's go ahead and rewrite this in factored form. This would be x minus 3, x minus 5. The second one would be x minus 5, x plus, that's a minus, x plus 1. And now I'm going to look at the different parts that I have here. So I have three things to consider. I have the x minus 3 from the first fraction. I have x minus 5, which occurs in each of them. And I have x plus 1, which is in the second fraction only. That will be the common denominator. Now what I'm going to do is rewrite each of these fractions with that common denominator by looking for the terms that they have missing. For example, in this first fraction it has the x minus 3 and the x minus 5, but it's missing the x plus 1. So in order to get that common denominator, I'm going to have to put an x plus 1 in the denominator. But whatever I do in the denominator, I also have to put in the numerator. So this will be my new numerator to get that common denominator. The second fraction has the x minus 5 and x plus 1, but it's missing the x minus 3. So I'm going to go ahead and put in an x minus 3 in the denominator. But whatever I do there, I also have to do up here. So I'll be multiplying this by x minus 3. So now I have a common denominator for each of those. My job now will be to subtract the numerators and keep the denominator the same. So this numerator will become 5x times x plus 1. This is a subtraction, so subtract x plus 2 times x minus 3. Now I'm just going to clean this up and make it look a little bit nicer. I'll do that by distributing the 5x and then foiling over here, distributing the x plus 2 over the x minus 3. That will give me 5x squared plus 5x. I'm going to have to distribute this negative at the same time here, so I'm going to be a little careful here. X times x is x squared, but we have a minus here, so that'll be a minus x squared. We have a negative 3x and a positive 2x, which is a negative 1x for our middle term. Distributing that negative would make that a positive x. And then 2 times a negative 3, our last term would be a negative 6, and again, distributing the negative would make that a positive 6. All of that is going to get divided by our common denominator of x minus 3, x minus 5, x plus 1. Now the only thing I have left to do is just to combine some like terms here. 5x squared minus 1x squared would be 4x squared. 5x and 1x is 6x. And then we have that 6 at the end. That is, again, over that denominator. And this actually is going to be our final answer. Now there are occasions where this could factor further, and that maybe one of those factors would be in the denominator. This is not one of those cases, although I can take a 2 out of the numerator, and you could certainly write that as 2 quantity x squared plus 3x plus 6. It's not necessary, so we'll call this our final answer.